Right, we have a 3-marker on bonding here. The question asks, explain why fluorine is a gas at room temperature. So because it's asking about its state at room temperature, it means it wants you to explain why it has a certain boiling point, right? So is its boiling point high or low? If it's a gas at room temperature, it means it has a low boiling point. So the question says, use the following words in your answer. That means we literally have to write this within the 3 points that we're going to write. And those words are energy, forces, molecules, and weak. So we need to understand what's happening here. This is fluorine. First thing you want to do is figure out what type of bonding are we dealing with. Fluorine is a non-metal. It's on the right-hand side of the periodic table. So that means we're dealing with covalent bonding here. Now within covalent bonding, there's 3 different types of covalent structures you come across. So there's simple molecular, there's giant covalent, and there's polymers. So fluorine, out of those 3, you need to think which one is it. Fluorine is a simple molecular substance. It doesn't have the word poly in it. And for giant covalent ones, you pretty much learn all of those as the allotropes of carbon or silicon dioxide. So that's graphite, graphene, diamond, fullerenes, or silicon dioxide. It's none of those, so it's not giant covalent. This is a simple molecular substance. So now you need to think back to your simple molecular substances. Fluorine looks very similar to this. So you can see here we have 2 Cl2 molecules. So think about having 2 F2 molecules here. We have 2 bonds involved here. We've got the covalent bonds, which are between the atoms, which are very strong. And we have the intermolecular forces, which are between the molecules. So when it comes to boiling a simple molecular substance, you need to think about the intermolecular forces, because those are the ones that break when you boil a simple molecular substance. It's not the covalent bonds. The covalent bonds are very strong. It's very difficult to break those. So these intermolecular forces are weak. They're between molecules. So we've used the word forces for intermolecular forces. We've mentioned that they're weak, and we've mentioned that they're between molecules. So let's write a point on that. So we can say the intermolecular forces between the molecules are weak, right? So we've used 3 of those words there. Now we just need to use the word energy. So because they're weak, they only need a low amount of energy in order to break. These need a low amount of energy to break. So those are 2 points there, but within it, we've got the 3 marks for this question. That's how you get 3 marks.